Aren't you tired of casuals trying to revive the old Tamiya motor cars when the local hobby stores always had them? To be honest, I kinda have. But what if we could take these model kits outside their racetracks and give them more control? So today, we're gonna convert them with a 3D printed chassis and make it remote controlled. So if you don't have a 3D printer, well, it sucks to be you. Kidding, if you don't have a 3D printer, you might as well avail one of the 3D printing services available in your area. The first step is to get into the internet to check out some Tamiya blueprints and remix our own design, as well as add our own tolerances for adjusting later on. I personally took the time to add the joints to animate in Fusion 360 to simulate the degrees of freedom the wheels have when turning. And for this model, it only has 25 degrees of freedom. In other words, it just looks cool, and we'll see if it works after printing. The thing about 3D printing is that it takes a long time to produce something enough for someone to get a haircut. Like me. Taking a print off the heat bed is made much easier with a spring steel plate, though there may be times we might still need our spatula. Removing the supports also felt satisfying. In this print, I forgot to properly set the retraction value, so I could notice a bit of stringiness. However, cleaning it off is a simple step. Now the model is complete, I think it's time to do the assembly. We have these tires. We'll be able to use them later on. Here's the shell. Yeah, this is what we need. It's something we can't replicate in 3D printing. Next, we have the tires. My concern about the tires is the center diameter is too small. I'm not sure if a screw will fit there, so we'll see as we go through. If ever, we might have to 3D print the wheels as well. Now, the main chassis, since we already printed our own, is over here, but we kinda don't need these. Here's some gears. We'll be taking these as well. We barely need... Oh, I see what we need. This guy. We'll take this later on. Some stickers. What else is in the box? Some safety precautions, we don't need those. Instructions. Yeah, we don't need those as well. It's good to go. I will just have to open this. This guy, the lock nut, or whatever you call it. This is what we need. Not this guy. Now it's time to open the package. Now we take our clippers and start trimming. I'm so sorry, plastic modelers. I know it looks terrible. Now we take the stickers. Now carefully slide this guy here. It fits well. The lock nut, if it fits, and it does. And it's time to cut the tires. So far, these are all the components we have. We just have to print a few more parts to continue. I'll show you a little trick with 3D printing with a snap of my fingers. Alright, now the print is done. Let's open this little package over here. Here's the screws we'll need. We don't need these metal sheets, so let's throw it away. And here's the motor and the shafts. For the steering wheel assembly, we'll take these two screws and insert them here and here. Tap the holes with this screw here. Slide it in here and screw one of them in place. Now that that is done, carefully set it aside and take this rod, one of the shafts, and remember we have to measure around 17 millimeters,
If you want the easy trick, screw it in place, even though it's 17.4 millimeters. Check the distance and take any masking tape, duct tape, electrical tape you have, whatever's around. Since it's harder to mark it with a pencil or a ball pen, you might as well add some tape. There we go. Now you're sure it's 17 millimeters on each side. Unfortunately, we don't have any strong clippers right now, so we're just gonna have to struggle with trying to cut it at those ends. Blunt, damn it. I think we just have to use these two. Try getting one of these wire cutters and try to trim it that way. Here we go. It helped a lot. Thanks. Slide it in. My brother to cut that little peg over there. Alright, measure 7 millimeters. So the steering mechanism works like this. This is the main chassis. A servo will be placed there, and the steering mechanism will be driven by the servo. And that's where the peg comes in, so that it will interlock this gear to the steering plate, so that it will be able to move like this. There's a hole in where the peg can insert through. All we have to do is to modify the servo motor so the peg inserts into one of those holes.
Bye, servo wings. Now the servo fits in perfectly. I guess it's alright to cut this now.
Let's try making a hole here first.
2mm drill bit.
Now you slap this guy on here.
Don't be afraid to apply a generous amount of super glue. Let it dry for an hour or so. Now we start reducing a bit of the gear. Alright, it should look like this. Once you cut it, reattach it to the servo and see if it fits the chassis. As much as possible, it should be flat down on the base. So this is how the servo will turn and control the steering plate. The next step is to attach the motor into the main chassis. However, the pin over there will obstruct the servo. So we have to remove this motor shaft in order for the servo to fit.
Once you cut the shaft off the motor, it's time to add this gear and slide the motor in place. And you will see it slip in perfectly.
Now take these two gears and shaft adapter and super glue them in place.
Slide in the shaft, make sure it's aligned, and take this super glue and apply a gentle amount of super glue around the area, but not directly to the shaft. And you will see it lock in place and it's well aligned. Make sure you take off the shaft so that the super glue won't bind closely to the shaft. Now wait for it to dry.
Here's the barrel spacer. Here's the gear mechanism we made. Take the main chassis and slide in the shaft. Slide in the spacer and then take the gear and slide it in as well. Then slide it through the other hole. And then take the motor to see if it fits well. It should be good to go. Now going back to mounting the servo, I printed one plastic spacer to fit in the spot over here and slide in the servo. Once the servo is in and is on top of the plate, take two 150mm Ziplocs and secure them in place. First, insert it through the hole in either side and let it pass through the back over here. Once it's in, you're free to secure it in place. Secure, double check if it slides. Take the other nylon Ziploc and secure the motors. To secure them better, use some pliers to pull the nylon. Once you're done, clip off the nylon. And there you go. Now, depending on your setup on how you want to control the motors, you may use Bluetooth or radio control. In our case, we will use radio control. Here we have an ESC, battery, and a receiver. We will connect the servo motor directly to the receiver. Turn it on and connect it to your
remote control.
Welcome to OpenTX.
Once it has binded, test the motors if it's working. Then try to connect the motors. Don't worry, as we will solder them later on. Toot, 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 toot. Thomas, you forgot something. These act like washers so that steering wheels will have less friction. Now insert these into the sides, then insert the rims, and try to drill a hole in these two rims for the front side. Take two M2 screws and insert it in the rim. Then insert the spacers. Alright, once it's in, apply the tires. Apply some grease over here. Now take your solder and solder the wire. Once it's done, reconnect and start trying to make it more compact. It took a while troubleshooting off the camera, though we managed to shorten the wires and solder them directly. All you have to do is to cut the shell here and there. Finally, the last step, sticker time. It's ready.
All I know is I just need her. All I know is you just need her. All I know is we just need her. All I know is you just need her.
Let's go. Hey guys, I'm Thomas Reyes. Thank you for watching. Like the video if you like it, and hit subscribe button if you haven't. If you want to see the latest and greatest projects, check out my Instagram page to stay updated. And see you next time.